Morning. Hearing will come to order. Thank you all for being here. The top priority of the Aviation Subcommittee, as well as me personally, is the safety of the flying public. Therefore, the Subcommittee has closely monitored the actions of the FAA, the NTSB, and Boeing in response to the battery incidents that took place earlier this year. We've called this hearing to learn more about the FAA and Boeing's actions to get aircraft back to safe operation. As we all know, in January, there were two separate incidents involving a lithium-ion battery on Boeing 787 aircraft, one on the ground in Boston and the second in the air over Japan. After ordering a review of all Boeing 787 critical systems, the Federal Aviation Administration issued an emergency airworthiness directive that temporarily halted the operations of 787s. In the 5 months since the incidents, the FAA and Boeing have worked to develop a comprehensive solution to the battery issues and have safely returned the 787 aircraft to service. As a key part of this process, the FAA and Boeing have taken a hard look at the certification of the 787. This review has focused on what worked, given that the safety of the aircraft itself was not compromised in either incident, and what needs or needed to be improved or adjusted. Although the NTSB investigation is ongoing and the Board has not identified the exact cause of the battery failure, Boeing has been able to narrow the possible causes of the short circuit to 4 or 5 basic things that they think were the cause. Based on that information, Boeing developed a comprehensive solution that addresses all of these possible causes. The solution presented to the FAA addresses issues at the battery cell, battery, and aircraft levels. In the end, the new battery design underwent over 200,000 engineering hours and was then subject to a rigorous testing and FAA approval process. Once again, the committee has been closely monitoring the actions taken by the FAA and Boeing. Initially, there was great concern about the possible implications of these incidents. In the last 5 months, we have made every effort to ensure that the FAA and Boeing are working together to develop a comprehensive solution. Therefore, the subcommittee had met several times with representatives of both the FAA and Boeing and received high-level briefings on the incidents and the comprehensive solution. Chairman Shuster, Ranking Member Rahal, Ranking Member Larson, and I received briefings by Boeing's CEO during the early stages of the investigation. The subcommittee has remained informed about the actions being taken by Boeing and the FAA at every step of the process. Moving forward, the subcommittee will continue to monitor the FAA certification process and the 787. To assist in this effort today, we will hear from the FAA and Boeing on lessons learned as a result of the 787 battery incidents and the comprehensive certification review. This hearing is not about attempting to lay blame on anyone. Instead, today we will take a constructive look at what has been learned from these incidents. It is important to remind ourselves that the United States aviation system is the safest in the world. This is due to the dedication and commitment of all stakeholders who, in situations like this, work together to ensure safety of the flying public. I'd like to thank both the FAA and Boeing for their participation today and look forward to their testimony. I'd like to ask unanimous consent that all members have 5 legislative days to revise and extend their remarks and include extraneous material for the record. Without exception, so ordered. I now like to yield to Mr. Larson for any statement you may make.
Thank you, Mr. Chairman, for calling today's hearing to review lessons learned from the Boeing 787 incidents. Mr. Chairman, I believe we should start this hearing by acknowledging that we are in an incredibly safe period for U.S. commercial aviation. We haven't had a fatal commercial passenger accident in the U.S. since 2009, and we owe a great deal of credit for that to dedicated safety professionals at agencies like the FAA and the NTSB. Additionally, the Boeing company has been a world leader in the airplane business for almost a century. It's maintained its leadership by making safety a priority. The Boeing 787 pushed the technological envelope. The certification itself was an 8-year process. The lithium-ion batteries, like many of the aircraft's design features, are new and a constantly evolving technology, not specifically covered by existing FAA regulations. We know the FAA worked with Boeing to develop special conditions that would ensure the safety of this new technology. and the process for developing these special conditions was collaborative, rigorous, and transparent. These conditions took over a year to develop and were published in the Federal Register for public comment. Nevertheless, we had 2 serious safety incidents involving Boeing 787 lithium-ion technology in roughly a week's time. These incidents caused the FAA and other international regulators to ground the 787 for more than 3 months. The grounding raised legitimate questions for the flying public about whether the certification process with the 87 worked as well as it should have. In response to these 2 incidents, Boeing devoted more than 200,000 engineering hours to understand the cause of these incidents and develop technical solutions to prevent or mitigate any further incidents. And likewise, the FAA stepped up its own involvement in the testing and analysis activities required to certify the new battery design. As a result, the 787 modifications certified by the FAA have been completed, and all the airplanes are now back in service. Mr. Chairman, we both agree that safety is always this subcommittee's highest priority. With the 87 flying safely again, now is the appropriate time for the subcommittee to review these incidents and glean lessons learned that could further improve aviation safety. In April, the Government Accountability Office raised concerns before the Senate Commerce Committee that, quote, the FAA staff had not been able to keep pace with industry changes and thus may struggle to understand aircraft or equipment they are tasked with certifying. The NTSB's independent investigation of the January 7 Japan Airlines 87 incident is exploring this key issue, and that should be completed later this year. The FAA is conducting its own review of the 87 certification process. Looking forward, Congress must ensure that the FAA is adequately staffed. The agency is positioned to understand and to challenge assumptions put forward by manufacturers regarding new technologies. I hope to hear from the FAA and from Boeing today about how the special conditions for the 87 were developed and whether they were strict enough. I'd also want to investigate whether the resources required for recertification of the 87 were enough. In February, I expressed concern at this subcommittee, at our subcommittee's FAA reauthorization hearing, that sequestration could negatively affect FAA certification activities. I'd like to hear from Ms. Gilligan whether she believes that sequestration, budget cuts, and hiring freezes are impairing the FAA's ability to attract and retain technical competencies required to certify new technologies. Also, I'd like to hear about the FAA's efforts to retain independent technical expertise from outside the agency when necessary to assist in the certification of new technologies. Lastly, I hope that we'll have time to investigate the lessons learned from this process and how the FAA will certify aircraft with lithium-ion batteries in the future. Thank you, Mr. Chairman. I look forward to hearing from our witnesses.
Thank you, Mr. Larson. I'd now like to turn to the Chairman of the full committee, Mr. Shuster.
Thank you, and thank you, Chairman LoBiondo and Ranking Member Larson, for holding this hearing today. And I appreciate the fact that our witnesses from the FAA and Boeing are here to testify before us. And as Chairman LoBiondo said, this is a constructive hearing, something we can learn from. When we look at the United States and the transportation system, the airline system, aviation system, safely transports over 730 million passengers a year, 70,000 flights a day. So it's the safest aviation system in the world, and that's due to the work and the efforts of the FAA, the airlines, the manufacturers, the controllers, other operators and stakeholders who make it a safe system to operate in. And then this committee remained in close contact with the FAA and Boeing after the incidents occurred and through final approval. The committee's oversight activities, it was apparent that throughout the process that everyone was working towards a solution, and they did that. We greatly appreciate the Department of Transportation, Secretary LaHood and Deputy Secretary Pecora, Administrator Huerta for personally meeting with myself and others on the committee. And when new aircraft with novel use of technology can experience issues, it's important that we address those issues early on in the process to make sure that we have safe aircraft. And this situation we were able to address. It does not mean they're unsafe. In fact, I believe they are safe today. The incidents, the FAA and Boeing's responses to the incidents, we're going to remain looking at these, again, learning from the process, because I believe there are valuable lessons to be learned from this. And I look forward to hearing, again, today from our witnesses Again, we'll continue this oversight and continue to closely monitor the FAA certification program. And as the 787 resumes normal operations, look again closely at what's going on, what's transpiring. And as I said, throughout this process, I think everybody worked diligently, worked together to get the 787 back up in the air, and that's positive for the U.S. economy. It's positive for the airlines and the aviation industry in America. So again, I'd like to thank the Chairman and the Ranking Member for holding this hearing today, and yield back.
Okay, thank you, Ms. Shuster. Now we'll turn to our first witness today, is FAA Associate Administrator for Aviation Safety, Peggy Gilligan. Ms. Gilligan, you are recognized.
Thank you. Chairman LoBiondo, Congressman Larson, and members of the subcommittee, thank you for the opportunity to appear before you today to discuss the certification of the Boeing 787. One of FAA's central roles is to certify aircraft and components that are used in the civil aviation operations. We've been doing this for more than 50 years, and right from the start, aviation products have often stretched the technological boundaries. Over the decades, we've enhanced our process and regulations. For example, for large aircraft like the 787, we've changed our regulations more than 130 times to keep pace with new ways of doing business and new technologies. For more than 5 decades, the FAA has compiled a proven track record of safely introducing new technology and new aircraft. As we continue to certify new aircraft, I want to make one thing very clear. We take that responsibility very seriously. To certify the 787, the FAA assembled a team of FAA
Excuse me, could you pull the mic a little closer, please?
Sure. Is that better?
Just pull it a little closer to you. Yeah, that's good.
Okay.
Thanks.
To certify the 787, the FAA assembled a team of FAA engineers, inspectors, test pilots, and scientists, as well as experts from industry, think tanks, trade organizations, and other civil aviation authorities, in addition to all the expertise at Boeing. The certification of this aircraft took more than 8 years, hundreds of hours of FAA engineering review, and 900 hours of flight time. A key tenet of the certification process is to plan for the unexpected, and this was the case in the 787. We required the manufacturer to design systems to meet certain performance standards. Then we required them to assume a failure and to design the aircraft so that it could be safely landed if a failure were to occur. Many layers of safety are built into the meticulous processes and the thorough design. For the battery, for example, we established 9 specific requirements to protect against a battery failure and to protect the aircraft if a battery should fail. One layer may fail, just as it did in the in-flight 787 battery incident. But the multiple safeguards built in and the procedures pilots are trained to follow enabled the pilots to safely land the aircraft. This is how the system works. Immediately after the 787 in-flight incident, the FAA issued an order that suspended flight to ensure that we had the time to consider the right solutions without compromising passenger safety. Our safety team worked thousands of hours alongside Boeing, and as a result of the battery system review, Boeing made several changes. They redesigned the internal battery components to minimize a short circuit within the battery. They insulated the battery cells to prevent propagation from one cell to another. They added a robust battery containment and venting system to prevent a problem in the battery from spreading to the aircraft. And finally, the company improved the quality assurance process at the battery manufacturer to ensure that the batteries meet our rigorous design standards. We've concluded our review of the redesign, and we have approved its operation. The aircraft is once again flying passengers safely around the world, and Boeing has resumed delivery of new 787s. We are confident that the new design will protect the safety of the aircraft and its passengers. The FAA is continuing to review the critical systems of the 787, including its design, manufacture, and assembly. We began this broad review, which includes the FAA certification processes, in January after the first incident. We expect to complete it this summer. Both these actions, first addressing the immediate safety concern and also doing an in-depth review of the product and the processes, are a standard way that we approach our safety mission. Some have asked whether the FAA has the expertise needed to oversee the 787's cutting-edge technology. Not only does the FAA employ a staff highly experienced in aviation, but we have access to experts across the country and around the world. We establish rigorous safety standards and make sure manufacturers demonstrate that the standards have been met. Our safety record shows just how successful we have been. What the 787 battery experience has shown is that neither the industry nor the FAA is perfect. But it also shows, as I noted earlier, that as aircraft are designed and built, we plan for the unexpected, and we make appropriate data-driven decisions to manage risk to protect the safety of the flying public. As we've learned with the 787 certification, the way to enhance safety is to keep lines of communication open between industry and government, to foster the ability and willingness to share information about the challenges that we all face. These solutions show the FAA and its industry partners continue to create an atmosphere where people work together, all in the pursuit of maintaining the highest levels of safety. That is why we are all here. But the FAA will never lose sight of the respective roles. But there is always a seat at the table for the bright minds from industry to help inform the best way to navigate the complex technological issues we encounter. It would be short-sighted to overlook anyone's valuable expertise. Mr. Chairman, I'm proud of the safety record we've achieved, and I'm confident we have the best people in the right places to meet our challenges ahead. That concludes my testimony, and I'll be happy to answer any questions you may have.
Thank you very much. Couple of questions that I have. During the two battery incidents, was the safety of the aircraft or the flying public ever in danger? Microphone.
Right. The first incident, as you are aware, occurred on the ground after the flight had been completed, all the passengers and crew had left the aircraft, and the aircraft was being cleaned. So in that particular incident, there was no risk to anyone during the operation. In the second incident, which did occur in flight, we believe so far that after the battery event itself, the remainder of the system operated in accordance with the standards. That is, it contained the event within the battery. Although we still do not have the root cause analysis completed by the NTSB, so that we do need to wait and see what the final results of that investigation are to see if there was any additional risk that we haven't identified yet.
Do you believe the FAA certification processes in place were sufficient to address and remedy the concerns raised by these incidents? Or should we relook at that somehow?
We believe that the certification process is really quite robust, and I think, again, the safety of the system indicates that the products that FAA and others around the world have certified do provide an appropriate level of safety. Having said that, we always are looking to improve the processes. We've learned some lessons from what we've seen already with these two events. We'll learn more lessons from the NTSB review as well as our in-depth review, and all of that will be rolled back into the certification process to improve upon a very sound, robust basis.
Understanding that we don't have the NTSB final report, what do you think the lessons learned from these two incidents are up to this point, and what is the FAA doing in response to lessons learned?
I think we've seen a couple of important lessons. The first is that we now have a much more robust process for testing lithium-ion batteries if they're used in aviation. The certification standards and the testing that Boeing demonstrated in the redesign will become the standard that FAA and other authorities around the world will use when we evaluate the level of safety provided by a lithium-ion battery used in an aircraft. So that's a very important lesson, and that's already in place. I think, in addition, we've seen some areas where we can improve our process. One thing we realized is that some of these new technologies are not just used in aviation, and there can be a community of experts who know something about the technology but have nothing to do with aviation, and we want to be able to reach that community. In this case, Boeing brought together a number of experts on lithium batteries, and we learned a great deal from them. So what we need to do is broaden how we reach out for comments on our standards and expert review to make sure that if there is a community of experts outside of aviation, we know how to reach them. We're also looking at some of the process improvements internally. Again, with new technologies, we're thinking that it's probably makes sense to have people who are not involved in that certification periodically review our work and the manufacturer's work to make sure, this is other FAA folks, but to make sure we aren't overlooking something or we haven't missed an assumption or we haven't asked a critical question. So those are the kinds of process improvements that we're already seeing would add value to our certification process.
Okay, thank you. Mr. Larson?
Thank you, Mr. Chairman. Ms. Gilligan, was this last month? We had Mr. Huerta in front of us, and he said that the FAA had announced a review of the certification process related to the 87, and that review is ongoing and so on. Specifically, you've outlined some lessons learned, but can you give us a timeline on when that review of the certification process will be done? Can you as well help us understand what the focus is of this particular certification review?
Sure, I'll be glad to. After the first incident that occurred in Boston, the administrator and secretary, along with Boeing executives, announced that we were going to undertake this in-depth review. With the second incident and then the airworthiness directive, we did lose a little time because a lot of the same folks needed to be included. So we actually kicked the in-depth review off in early February, and they've been working pretty much full-time since then with an eye toward completing their review in the summer. So what they've done, what that team did, was go beyond information on the battery, but to look at all of the operational data that we had from the aircraft since its introduction into service, and to see if there was any trend, any set of incidents that needed to be looked at more thoroughly. And they've identified a couple of areas, and they are doing what we call deeper dives into those areas to see what it shows us. And from that, we expect that they will make some findings and recommendations on process improvements and perhaps other actions that we or Boeing or both will need to make. I think
well, at least I'll look forward to seeing the results of that review and getting briefed on those. Since you're in that process, I won't go into too much detail with you right now. But a question about that arose out of this incident isn't a new question, but I want to give you an opportunity to address it. And it has to do with this term some folks have used in the media called self-certification, that this is one of the dangers of self-certification. Can you help us understand why the FAA would argue that this is not self-certification? And let me give you the goalpost. Self-certification would be company A goes and does what it does and comes back to you and you check the boxes, right, versus FAA does everything and then hands it to the company and says, to company A and says, do this. So if those are the goalposts, I'm sorry, the bookends, I got my analogies wrong. Those are the bookends. How would you characterize the certification process? Well,
we would agree that the term self-certification is a misnomer because Boeing doesn't certify anything. The Boeing company, as the manufacturer, is responsible for demonstrating that their product meets all the standards that we have set. They have to have data and information and analysis that shows that they've met those standards. And then the FAA or someone who works on our behalf.
Sorry, this would apply to someone who makes a vortex generator this big and someone who makes an engine for an airplane as
yes.
well. Right. This applies to anybody looking to build a part for an airplane here in the U.S.
Right. The certification process is fundamentally the same.
Right.
There are some small parts that are treated very differently, but you're right. The major systems or parts of aircraft go through the certification process. It might be easiest if we if I can describe it kind of through an analogy. We sort of see it like taking a test. FAA is the one who sets the criteria for passing the test. We tell the student, the applicant in this case, the manufacturer, what it takes for them to pass the test. They have to take the test and pass it, and then we, or people on our behalf, grade the test and determine if they passed. That's really how it works. The FAA and our designees, who we appoint based on, obviously, the authorization provided by Congress for the administrator to appoint people to act on his behalf, are the ones who make the determination that the standards have been met.
Let's beat this dead horse a little bit. The analogy about the tests in school, because on page 5 of your testimony, you discussed the lithium battery literature. Mm-hmm. So part of what you did then was to review the available lithium battery literature. included consideration of the hazards of other battery technologies, such as nickel cadmium and presumably lead acid batteries as well. But the end result is then you created a test for these special conditions, but the test itself perhaps was bad.
Well, we haven't seen the data that says that the standard that we set was bad. In fact, if you compare the special condition to the regulation that was on the books for batteries, you'll see that we made it much more robust. Lithium batteries provide higher energy at lighter weight. Sure. That's why manufacturers wanted to use them. But because of that higher energy, they also pose a different kind of risk than other batteries. That's why the standards we had in place didn't fully address the risks that lithium-ion batteries could introduce, and that's why we added additional requirements and even made some of the original requirements even more robust for the purpose of the manufacturer showing that the lithium battery was sufficiently safe for this application.
The conditions state that lithium-ion batteries are significantly more susceptible to internal failures that can result in self-sustaining increases in temperature and pressure than their NICAD or lead-acid counterparts. Did those hazards cited in the special condition trigger a heightened level of FAA involvement in the certification or compliance activities for the battery based on that risk analysis? And then can you explain the additional actions FAA took?
So, right, yes, we set the new standard in consultation with the manufacturer and the industry. We put that standard out for comment. We received some comments, again, from people in the aviation industry, and this, again, is where I think we saw a lesson learned. We need to make sure that that kind of special condition also went to experts on lithium-ion batteries who might have been able to help us understand better how to improve it. So that's something we'll look at changing in the future. Then it was for Boeing to, in accordance with the certification plan that we approved, Boeing had to do tests and analysis to show that they had met all the requirements of the special condition. And we had designees on our behalf who made the finding that Boeing had shown that they met those standards.
What's a designee on your behalf? Is that an FAA employee?
No, again, under our statute, we've been authorized for many years to have the administrator appoint individuals or organizations to perform some of these functions on our behalf. We then have a program at FAA where our engineers, in this case, oversee the performance of the individual who's designated or the organization who we've given a designation to make sure that they are properly performing their functions, that they are making the same findings the FAA engineer would have made if they had done it themselves. So it's a way that we can leverage our resources because there are a large number of approvals that are required in a manufacturing program or in our operational environment as well. And a cadre of FAA employees would be extremely large, probably unmanageably large. So we leverage our engineering expertise through the designation of individuals and organizations to act on the behalf of the administrator in accordance with the FAA Authorization Act.
The designee program has been around since '38?
The designee program has been around since the late 1930s. And again, I think it was a very elegant solution that the Congress came to, realizing that there would be a number of these repetitive approvals that we would want so that the public saw that aviation was safe, but that there would never really be a federal cadre of employees who would be sufficient to carry that out. So we've been able, as I say, to leverage FAA resources by appointing individuals to act on our behalf. It is considered quite an honor to be an FAA designee. It is taken quite seriously, and we continue to oversee that those individuals or the organization that holds that approval is performing properly. We have the ability to withdraw it if they're not, so we manage it in that way.
Right. I have further questions, but I'll take a second round. Thank you.
Mr. Meadows.
Thank you, Mr. Chairman, and thank you, Ms. Gilligan, for being here and obviously being well informed on the process, and I just compliment you on that. It's my understanding that when the NTSB gets involved in an investigation, that all the parties with the investigation are severely limited in their ability to respond or communicate either to the public or the media, and they're even restricted at times in their communication between the parties. For example, between the FAA and Boeing, or between Boeing and Japan Airlines. And these communications first have to go through the NTSB for clearance. Specifically, are there any reforms that you could see that the FAA or the NTSB could make that would allow this process to work more effectively in terms of investigating incidences while still allowing them to respond to the public and to each other?
Well, sir, I think the party system which the NTSB uses does allow for all of the interested organizations that are involved to have a forum to make sure that they are sharing information about the particular event or incident or accident. In this day and age, with the instant demand by media and others for, immediate information, it is sometimes difficult to make sure that things that are unique to the accident or incident being investigated don't get into the public domain before the organization responsible for that investigation has an opportunity to consider how it should be presented. I do think in all the cases I'm aware of, we are able to work out the needed exchange of information so that the NTSB is confident that they are controlling, I guess, the information about the accident itself, while meanwhile, as you point out, we and manufacturers and others, we have other safety information that we need to share to make sure.
Excuse me, you hit two key points, though. You keep referring to accidents, and this wasn't an accident, it was an incident. And there's a big difference there, because I think that this is a compliment to the FAA and to Boeing and to a number of the situations, because it wasn't an accident. It was something that got identified as an issue. And I guess, when we had previous testimony with the FAA, the administrator said, well, Boeing's taking responsibility, but we know that there was a number of other issues that weren't specifically related just to Boeing, and yet that information never got out. So, it's not an accident, it's an incident. So are there any reforms that you would recommend to the process right now?
Well, again, I think we have a very good working relationship with the National Transportation Safety Board. If we are ever in need of safety information and there's any question as to whether or not we can receive it, those questions are very quickly cleared up. And I know we have also worked with the NTSB and Boeing and others involved in these investigations.
So there are no reforms that you would recommend?
I don't know of one offhand, sir.
Okay.
I honestly don't.
Well, then let me ask you a different question then. When they get involved, when the NTSB gets involved, how does that affect your ability to investigate, or does it change at all? If they're involved or if they're not involved, does your process change at all?
It's sort of like there are two parallel tracks. We support, in fact, many of our technical experts provide their technical expertise to the NTSB. As you know, NTSB is a small organization. They certainly don't have depth of expertise in all of the areas of aviation. So we provide, as do other parties to those events, those investigations, we provide technical expertise.
So does it limit your ability to investigate at all?
No, on a parallel track, we have other independent responsibilities because of our authorization to make sure that we are understanding if there are any immediate safety of flight issues or things that go beyond what may be the probable cause of that accident. So we very much try to separate that out, and we do our review to see if there are safety improvements we need to make while they do their investigation.
My time's running out, so let me ask you, if you had legislation coming from this committee that said that we would allow for a little bit more public disclosure on incidences and maybe keep that limited public domain on accidents, is that something that the FAA could support? If you had legislation coming from this body, is that something you'd welcome?
We certainly could follow whatever direction along those lines that might come through legislation. I think.
But would you welcome that?
Sir, I guess we'd really have to see what the language is. But I understand your point. I do think that incident review needs to be an open exchange of information by all of the safety professionals so that we can be sure we're going to prevent something that could be prevented because we understand what happened. And anything that would support that, we could support.
I yield back. Thank you, Mr. Chairman.
Thank you, Mr. Williams.
Yes, I want to say thank you for being here, Ms. Gilligan. We appreciate it. First of all, I'm going to ask you an important question. Would you feel comfortable flying on a Boeing 787?
Yes, sir.
Okay. Are you doing anything to change the skill set of your workforce in aircraft certification to move to a more risk-based system level approach to safety oversight?
Yes, sir, we are. We do see that the level of safety in the system now is at an all-time high, and the only way we're going to continue to build on that is to make sure that we are analyzing what's occurring, that we're finding things before they cause catastrophic failure, and we're able to fix it. So we are moving toward that kind of approach, which is identify risks, identify what you can do to mitigate, manage, or eliminate that risk, and oversee that implementation to make sure it's been effective. That will add to the skill set of our workforce, but on the certification side, we'll always need, obviously, aerospace engineers and other kinds of engineering expertise. But we're looking for a cadre of folks who have that engineering expertise and also the ability to do data analysis to really inform how they make their engineering decisions.
One other question, which you basically touched on it just a second ago, but simply put, do you believe that Congress needs to take additional actions as a result of this, of the battery incidents? Do we need to get more involved?
No, sir. I believe, as both the chairman and Congressman Larson pointed out, we believe that this is a demonstration of the system really working well. The reality is these are complex pieces of equipment and things will go wrong, but we need to make sure the airplane can land safely, and that's what we did.
Less government's the best government. Thank you for being here.
Thank you, sir.
I yield back.
Mr. Larson? No, he doesn't have questions.
Ms. Gilligan, could you compare the level of involvement in the certification activities associated with the redesign of the battery with the certification of the original design, and explain what, if any, actions as well as direct involvement the FAA took?
Sure. I think it's important to realize that after the second event, the in-flight event, we determined that we had an unsafe condition, and that always drives a higher level of FAA involvement. So we worked very closely with Boeing for thousands of hours to understand what were the risks. Boeing did a very in-depth analysis, brought together a team of experts on lithium-ion batteries to understand, since we didn't know excuse me, the root cause of the two events, we needed to understand what was the group of things, what were the things that might have resulted in either one of those events occurring. So Boeing identified those areas. That led then to what design changes needed to be made to address those risks, and the evaluation and testing to demonstrate that those designs would be effective. And we were with them pretty much every step of the way. There was a list of about 20 tests that needed to be performed. We FAA employees witnessed most of those tests on this redesign because, again, we were dealing with an unsafe condition, and we really needed to get to the root of that to be able to solve the problem.
So then, so you've characterized how the FAA was involved. Can you characterize the I don't know, the amount of time directly involved?
We have some hour counts. I hesitate to use them only because I hesitate to use them. So we've estimated about 7,000 hours, but it's important to understand for the work on the airworthiness directive, we also collect a lot of our overhead kinds of time. We have a lot of our executives and senior managers were involved in the work on the AD. Their time is included in that number. In a standard certification, that isn't always, the manager time isn't always accounted for in the same way. But with that exception, we spent quite a number of, again, thousands of hours working with Boeing.
What is this? What is the certification process, FAA's involvement in the certification process of the redesign tell you about your future involvement in the certification of the use of lithium-ion batteries in, you know, in the next airplane, whoever makes it?
Well, again, we will use the same kind of enhanced testing and analysis because we've seen how that can really show what will happen to the battery and whether or not the design really meets our standards. Whether or not we would delegate or ask our designees to provide, to make the findings of compliance will very much depend on the expertise of the applicant, the expertise of the designated organization or the individuals in that company. So a lot of, it's always kind of a case-by-case determination. But I think we will continue to keep our eye on applications for the use of lithium batteries to be sure that we are, that the testing and the standards are as robust as they need to be.
Have you changed the literature review? Literally, it might sound like a snarky question, but if the first lit review didn't of lithium-ion batteries did not indicate to you, or that is the FAA, of a testing regimen that would result in the similar incident that we saw with JAL or ANA, has the body of literature changed?
Well, again, I think from the expert panel that Boeing put together, we did learn that in the intervening years, more has been learned about lithium-ion batteries and their risks and how to test for those. I do think it's important to note, and I'm sure that Mr. Sinnett will in the next panel, in order for Boeing to reproduce the events that occurred in the two incidents,
right,
it was an extremely difficult test. It really pushed the battery much, much further than I think anybody realized it would need to be pushed, if that's the right way to describe it, in order to replicate what occurred in the two incident batteries. So I do think we have a very robust set of tests now that we are confident reflect the best knowledge on lithium-ion batteries today, and we will continue to monitor. We have the RTCA right now, a standards organization that helps us set standards, working on testing standards for small and medium-sized lithium batteries. We will, I think, task them to go back and continue to review the application of large lithium-ion batteries to make sure if there are changes in that literature, we're on top of it and we're able to incorporate that if we need to.
Didn't the RTCA's standards for testing on lithium-ion batteries change in the 2008 timeframe?
They actually, that was the first time they issued standards on our behalf. You know, they
Yeah.
provided standards.
Were those standards different than what was were they different than what the lithium-ion batteries were then being tested under?
They were different than how Boeing demonstrated compliance with our original set of standards, because they had a standard that would have allowed for the battery to be recharged, and in the Boeing design, they had determined that they would not permit the battery to be recharged, so that was not a standard that needed to apply. There may have been other differences, but they were not, I don't think we considered them substantial.
Yeah, who participated in the RTCA panel to look at that?
Oh, RTCA is a way that we bring together a large number of experts.
Right.
It was quite a large panel, as I recall, and we've got the list of people and organizations, but they were...
Was the FAA involved?
Oh, yes.
Directly in
that? RTCA takes these assignments from FAA. We asked
Well, I know they take the assignments from you,
Oh.
but
yes,
the FAA's
yes.
folks were there.
Yes, we had, somewhere between 5 and 10 participants in the course of the development of the standards, both to help inform the other experts about how FAA uses standards and those kinds of things, as well as to make sure we had a group of people who really understood the standard when we received it.
So it's a battery. So then was the lithium-ion battery standard that came out in 2008 from RTCA, their recommendations from RTCA, were those incorporated in testing or retesting lithium-ion batteries for the use in large airplanes?
The standards really provide a manufacturer with a method of how to go about showing compliance to the performance standards that we set. So we did not require anyone who already had an approved lithium battery application to go back and retest using the RTCA methodologies.
And why not?
Well, again, we had developed the special conditions in accordance with our counterparts in Europe. Airbus A380 was using some small lithium batteries as well, so we had already all agreed on what that standard was, and Boeing had at that time provided sufficient data to demonstrate compliance with those standards. So there was no
With the new standard?
no, with the standards that we applied. In aircraft design, it's very difficult to go back and cause existing products to be retested in accordance with some new standard or new information that we may get, unless something in the new information suggests that there is an unsafe condition in the old existing product.
And if I may, and you're arguing there was nothing in the newer standard that indicated there was something unsafe in the
That's correct.
in the existing standard.
That's correct.
Yeah. All right. Thank you.
Mr. Riddell?
Thank you, Mr. Chair. Appreciate it. Thank you so much for your time. I had two questions. The first, sorry, I had to step out for a second. Apparently, the first was already covered. It's in reference to the organization designation authorization, and I hope that we can work together really to make sure that this permitting process of these regulations that at times are incredibly burdensome for the industry, that we can work together to make them more efficient, streamline them, because at the end of the day, a lot of these costs for the entire industry, they have to get passed along to us who want to buy plane tickets. The other thing I just wanted to touch upon was budgeting. We know how sequestration has been difficult, to say the least, for the FAA, especially when it comes to prioritizing. I would ask you, what guidance can our committee here give the FAA in the future for future reauthorizations to better facilitate prioritization of funding as our Republican House continues to enact cost savings on behalf of our American taxpayer? Second part, what specific spending latitude will ensure that the FAA continues to meet its duties of oversight and efficiency for airplane manufacturers?
Well, if I could start with the second one
Sure.
first. Excuse me. First, I think we are very appreciative of the work that Congress did to allow the administrator the flexibility to move some funding within our different accounts at the FAA so that we could avoid furloughs this year. I think, you know, the idea of losing 10% of everyone's work time would have had a tremendously negative impact on some of the certification projects that we have underway. At the same time, we still are looking to save over $380 million at the FAA, and that obviously will have its impact as well. Right now, we are in a hard hiring freeze, for example, so we see pockets where there are people have left, resigned, retired, whatever, and it's having a harder impact in some small offices and those kinds of things. As to how to help us set our priorities, I do think the last reauthorization was very helpful, provided a number of opportunities for us to work with our industry, to review our certification processes, to try to find what it is that causes it to be burdensome or where there may be inconsistent outcomes among different offices, and provide us a real opportunity to work with industry to try to improve those. So hopefully you'll see some results from that, and that might well inform additional authorizations that would be useful going forward.
All right. Again, thank you so much for your time. I yield my time, Mr. Speaker.
Ms. Johnson?
Thank you very much. Let me apologize for being a little late. I had to go to another committee, and I hope you haven't answered these questions. But what I'd like to know is what key lessons have you learned with regard to this January Japanese Airlines incident, and will you summarize the process that FAA uses to create special conditions for new technologies, and why are special conditions necessary?
Sure. If I may, again, I'll start with the second one first. The special conditions is a tool that we have to allow the introduction of new technologies, most of which enhance safety, before we've had an opportunity to go through an extended rulemaking process. So special conditions, and in this particular case, the special conditions related to lithium-ion batteries built off standards that we had always had in place for traditional batteries. But the special conditions specifically identified the higher risks that are posed by lithium-ion batteries and provided for a more robust demonstration of protecting from those risks. So special conditions are really a way of building off what we know to allow the introduction of new technology carefully, making sure that we set a little bit more robust standard for something that's new or novel before we just allow it into the aviation system. As to lessons learned, I'd mentioned before, we're still waiting for the NTSB's final investigation report on probable cause, and we think that will help inform some lessons. And FAA and Boeing are doing an in-depth review of the certification process, and we expect to learn lessons from that as well. But there are some things that we've seen already. I think the first and most important is we have identified a more robust testing regime, excuse me, to be used for testing lithium-ion batteries. Excuse me. Boeing used that in the redesign, and that will be the regime that FAA will use going forward. So I think that's an important lesson. We've already raised the safety bar that much. In addition, we've identified that with new technologies, there oftentimes are experts who are not involved in aviation, but are experts in that technology. And we need to find a way to make sure we're reaching that community of experts to help us make sure that when we introduce new technologies, we understand everything that can be known at the time. So those, I think, are a couple. There are those kinds of process improvements as well, where we need to enhance communication between the manufacturer and all of the sub-tier providers that they buy parts from. FAA needs to be monitoring that more closely as well. So there are several process improvements that we're going to pursue as well.
Thank you. In your written testimony, you discussed the use of aviation experts outside the agency to resolve technical problems, noting certification of aviation products and systems is not limited to the participation of a single certifying entity and manufacturer. Please explain what steps, if any, the FAA takes to bring this independent outside technical expertise to bear on the challenges associated with the certifying of the lithium batteries for the use of Boeing 787.
Yes, ma'am. As we were just talking, there's an organization called RTCA, which is a standard-setting organization that FAA uses along with with SAE, another similar organization. Through those groups, we pull together experts on the technology. So again, at the RTCA, we had a wide-ranging panel of experts with aviation experience, with lithium battery experience, to help us build the standards and the description for how a manufacturer would demonstrate that the lithium-ion battery was safe. So we do have a lot of mechanisms in place that let us reach experts around the world on the particular technologies that we're trying to address.
Thank you very much. Thank you, Mr. Chairman.
Mr. Davis.
Thank you, Mr. Chairman, and thank you, Ms. Gilligan, for being here today. I apologize for coming in late. It seems to be the nature of our business to double book things, but I know you mentioned you had some responses to organization, designation, authorization. I'd like to just ask you quickly a couple questions to have you expand on that. And with fewer resources on the horizon for FAA across all offices, how will you further utilize ODAs and that delegation to meet the growing certification workload for new products at both Boeing and throughout the American aerospace industrial base?
Thank you, sir. As we discussed a little bit before, FAA has for many, many years leveraged our internal resources by using either individuals or now organizations to whom we delegate authority to act on our behalf. It is a key way that we are meeting the safety requirements for certifying products, and we see that expanding over time. The ODA is a relatively new authorization, and we are learning, and so are the industry applicants learning as we go. But I expect that we will see that, if not mushroom, certainly grow substantially, because it is a way that we can leverage our resources and assure the safety of the product at the same time.
Okay, thank you. Now, at Boeing right now, are you overseeing all of the, the entirety for inspections that would normally fall under an ODA or under their employees?
Oh, no, no. The Boeing company has an ODA. It is quite a robust ODA. We work very closely with them. We continue to provide oversight of the ODA. We need to assure that they are performing their authorizations on our behalf appropriately. I think, as we see in this hearing, there's always a balance between how much we delegate and how much involvement the FAA has. And it's a delicate balance that we watch closely, but mostly what we want to assure is that those who are operating or acting on behalf of the administrator do so in the same way as an FAA engineer would have operated, and we see that that's very much the case at the Boeing ODA.
Okay, so Boeing is still completing some delegated tasks that they've normally completed, and you're just doing your oversight.
That's right. We provide oversight of the ODA.
All right. I yield back to balance my time. Thank you for your time today.
Mr. Duncan?
Well, thank you, Mr. Chairman. Like the others, I had to be at another hearing that started at 9:30 before this one, but so I don't know if this has been covered or not, but the next witness is going to testify that Boeing put this 787 electrical system under an astounding amount of testing, 5,000 hours of component testing, 25,000 hours of laboratory testing, 10,000 hours at the airplane level, simulation of equivalent to 132,000 flights. In the FAA study of this, have you been able to determine why, after all this testing, did this problem not show up before? Is it just a fluke, or?
Mr. Duncan, again, we haven't seen the root cause analysis or the probable cause determination for the 2 individual incidents from the NTSB. We agree with Boeing that with all the testing that was done for the original certification, we did not see these events manifest themselves. We also know that when we introduce new products, after all of the engineering work that's been done, we often see something in operation that either we did not anticipate during certification, or where we see one of the assumptions that we built off of was just not accurate. So it's not uncommon for us to learn from the new product when it's introduced and to make improvements. And that's what happened here. We had 2 events. We went back and analyzed them. Boeing redesigned the system. We were able to approve that redesign, and the system and the aircraft are safer for it.
And I assume it's just a coincidence that both of these carriers happen to be Japanese carriers, as I understand. But is there something that these carriers require, or that the Japanese government requires, that's different from what went into the other 787s?
No, sir, not that I'm aware of. Right now, we really are looking at the aircraft, the design, manufacture, and assembly of the aircraft to see if there's anything that we may have overlooked that might have contributed to these 2 events. And if so, we'll address those based on whatever the data shows.
The FAA requires manufacturers to assume or prepare for problems occurring, and in this, and have a plan for mitigation to take care of these types of situations. And apparently, you didn't find that this plane was at risk at any time, and no one was injured. So, from that standpoint, the system worked. Would that be a correct statement?
Yes, sir. Again, until we see what the probable cause was, it does appear that although we had the failure within the battery at the cell level, that the rest of the design, which met our standards, did contain that event, and the aircraft was not at risk and was able to safely land. And you're right, that's very much a tenet of our certification process, to design so there won't be a failure, then assume there's a failure, and design so that the airplane can safely land. And in that regard, it appears everything, after the event occurred, it appears everything worked as it was intended to work. But again, we'll need to see what the NTSB results show.
All right. Thank you very much.
Okay, Ms. Gilligan, we thank you very much. Appreciate it, and we'll move on to second panel. Mike.
Thank you, sir.
Okay, our second witness today is Mike Sinnett, Boeing's chief engineer for the 787 program. Mr. Sinnett, you are recognized for your statement.
Chairman LoBiondo, Ranking Member Larson, members of the committee, my name is Mike Sinnett, and I'm the Vice President and Chief Project Engineer for the Boeing 787 program. It's my pleasure to appear before you today, and I want you to know that Boeing is committed to supporting your work in any way that we can. Mr. Chairman, Boeing's highest priority is the safety of the passengers and crews who fly on our airplanes. Every Boeing airplane incorporates the broad, deep, and ever-increasing knowledge we have gained from nearly 100 years of designing and building airplanes. Our design approach is data-driven, with risk carefully assessed and managed. Our designs feature multiple layers of protection and redundancy of critical systems so that no single component failure or combination of failures, even extremely remote, can endanger an airplane. Mr. Chairman, flying is as safe as it is because industry and government work together day in and day out. The 787 illustrates that commitment to cooperation. The design process started with a review of everything the industry and its regulators have learned about designing, building, and operating safe airplanes. I can attest to the team's strong focus on safety and to the strength of the certification process, which was more rigorous for the 787 than it was for any of our previous airplane programs. When our airplanes enter service, we continuously monitor their performance, analyze the data we collect, share safety-related findings with customers and regulatory authorities, and work with all parties to incorporate lessons learned into the active fleet and into new production and designs. The result is an exceptional, safe, and reliable airplane. Over its first 15 months of service, the 787 achieved a schedule reliability rate of 98.2%. That is better than the 777, which had been considered the best in its class up to that point. At the end of that 15-month period, we experienced 2 battery failures, and as we explained at recent NTSB hearings, both incidents, while serious, demonstrated the effectiveness of our design philosophy. The airplane's redundant safety features worked. They prevented the incidents from jeopardizing the passengers and crews. With that said, the work done following the 2 incidents revealed ways we could improve the battery system even further. Boeing devoted more than 200,000 engineering hours to develop a comprehensive solution and worked closely with the FAA to test and certify these improvements. Through changes to the design of the battery, the manufacturing process, and the addition of a steel enclosure, we added protections that reduced the likelihood of a failure and further ensure that should a failure occur, there will be no significant impact to the airplane. Mr. Chairman, I would like to turn to certification because I know that is a subject of great interest today. All of our airplanes are certified by the FAA, which is recognized globally as the gold standard. A key component of every airplane certification is the process for delegation of authority. Delegated authority furthers the top priority of industry and government, which is safety. The ability to delegate authority for routine tasks enables FAA specialists to focus on the highest priority issues. Organizations that demonstrate strict accountability to certification requirements may receive what is called Organization Designation Authority, or ODA. It is a privilege that is hard to obtain, and it carries serious responsibilities. Notably, the FAA remains firmly in control, and ODA holders are governed by stringent requirements that include an FAA-approved process for selecting and training individuals to perform these delegated tasks. I can assure you that the members of the Boeing ODA are held to a very high standard and are backed fully with the support of the Boeing company. As mentioned, the certification process for the 787 was the most rigorous in Boeing's history. It took 8 years and involved 3 times more conformed tests than the 777 certification program, 3 times more data submittals, twice as many airplane ground tests, and 3 times more integration tests. In closing, I would like to reiterate that certification is not the end of Boeing's involvement in the safety of delivered airplanes. We collect and analyze enormous amounts of operational data And when we spot a safety issue, we address the issue so that safety is maintained. This ongoing commitment to safety and the collaboration we find across aviation, coupled with our in-service monitoring and data-driven risk management approach to designing new airplanes, are key reasons that flying is the world's safest way to travel. Flying today is 70 times safer than driving, and in recent years there have been 0 deaths from airline accidents here in the United States. None of this is happenstance. Mr. Chairman, this concludes my remarks, and I'll be happy to answer any questions. Thank you.
Thank you. Could you tell us what you believe the lessons learned were from these 2 incidents, and what, if anything, you're doing in response to them? I mean, other than the fixes, which I know are in, being put in place.
I think the first thing that I think of is that because of these incidents and the work that followed, Boeing and the team that we worked with advanced the state of the art for understanding and testing lithium-ion batteries. The test protocol that we had gone through up to this point had reflected the previous state of art of the industry, and we worked following these incidents to push the state of the art so that we could cause a battery to fail in a similar way as it failed on the airplane. So this was one of the areas. I think we also learned a significant amount about how to improve the processes in the manufacture and quality control of batteries, of lithium-ion batteries. And lastly, and I think most importantly, these incidents validated our design philosophy, which is that no single fault can put an airplane at risk, and no combination of faults, even extremely remote, can put the airplane at risk. And again, these incidents revalidated that design philosophy.
Some have suggested in the aftermath of the 2 incidents that somehow the FAA certification process was in some way lacking. How would you respond to that?
I would disagree. I believe that the certification process for the battery and for the airplane was extremely robust. The process takes into account the risks of a component failing, and the process takes into account the resulting impact on the airplane. And as Ms. Gilligan pointed out, while the incidents occurred and the battery did fail, the failure itself was contained at the battery level and did not put the airplane at risk. And the certification approach ensures that that's the outcome. In a machine as complex as an airplane, there can be components that fail. We take those failures very seriously and we work to address them. An accident can be the cause of multiple links in a chain that fail, and any time we have an incident which can be considered the break of the first link in that chain, we take it seriously. The incident was referred to as potentially impacting safety, and that's because the first level of redundancy was compromised, and that's the first link in the safety chain, and so we take it very seriously.
Okay, thank you, Mr. Larson.
Thank you, Mr. Chairman. Mr. Sinnett, back to the first question I asked Ms. Gilligan about self-certification. If you could imagine again the bookends being where people call it self-certifying, where they give the company just go do something and come back and tell us what you did, we'll check the box, versus the FAA crawling all over it every day in control and then says, here, take it and do this. How would you characterize the certification process if those were, in fact, the bookends?
I would say that it was somewhere in the middle. The way the delegation works, the FAA looks at the tasks at hand, and it considers which tasks are safety-related, and it retains those safety-related tasks. In areas where the tasks are more relatively mundane, typical of what you do day in, day out in the cert process, they may delegate those tasks to the delegated organization. In the case of the battery, the initial battery certification, the FAA retained the items that were inherently safety-related. For example, the FAA retained approval of the certification plan. They also retained approval of the safety assessment following all the testing of the battery. Those were the 2 items that were most important in establishing the safety of the battery system and in assuring that as the applicant, Boeing, showed compliance, that the FAA was able to find compliance to the safety-related aspects. The other things that they delegated, things like test setup conformity, witnessing of certain environmental tests. Those aren't necessarily germane to the safety of the overall system and the overall design. Really, the keys to the kingdom there are the certification plan itself, how we propose to show compliance to all the rules, and then the safety assessment, which ties all of the analysis and the results to the end safety product.
Okay. Can you talk about the what you call the new state-of-the-art in testing, the old state-of-the-art, if you will? We've discussed, and NTSB has discussed this nail penetration of a battery, and perhaps I think we know now that probably should not have been a standard. Can you talk about what was the old state of the art and what you think the new state of the art on testing of lithium-ion batteries are for this size of a?
Sure, sure. In the past, the failure modes associated with large lithium-ion battery cells there were really two types of failure modes. One was a severe failure resulting from an overcharge condition where the cell contains more energy than it was ever designed to contain because of a failure of the charging system or a failure of the charging procedure. That type of failure has led to open flame resulting outside of the battery cell, and has been an area of great concern from a safety perspective, which is why the charging system comes under such scrutiny and is so carefully designed. In the NTSB factual report, they've set aside any concern about overcharging as being one of the potential failure modes of this battery. The only other failure modes that we're aware of are failure modes that result from short circuits inside the battery due to a number of different causes. Regardless of the cause, when those short circuits occurred, the net result at a cell level was simply the use of there's a burst disc on the side of the cell that opens when the cell pressure and temperature rises to allow the cell to safely vent. In all other cases for a battery failure, for a cell failure, the only thing that's resulted is that disc opening and the battery venting the electrolyte, which looks like smoke to you or I, but it's venting electrolyte with no flame. These particular cells had undergone more than 2 million hours of operation on the airplane without a failure, and had undergone millions of hours of operation in another industry also without a failure. The test, state-of-the-art at that time, was a nail penetration test, and when that nail penetration test was performed, it replicated every known failure mode of the cell with the exception of overcharge. And so while the cells would short circuit, their temperature and pressure would increase. They would vent this electrolyte, which again looks like smoke, but in no cases were there ever flame, and in no cases was there ever propagation to another cell inside a battery. For that reason, it was considered state-of-the-art through, again, millions and millions of hours of operation. On the JAL airplane and on the ANA airplane, what we saw was some type of internal short circuit. We don't know yet what the root cause was because that's still under investigation. But the net result was a more energetic release of energy from the cell than we had seen either through the nail penetration testing or from any of the previous testing. And so to replicate that, we had to put a significant amount of energy into the cell without overcharging. The only way that we knew how to do that was to wrap a cell with a heating element and put on the order of 300 kilojoules of energy into the battery in the form of heat to heat up the cell so that it would burst its disc and vent the electrolyte. What we found in that process was that it was energetic enough that it released enough heat to cause other cells in the same battery to vent as well. And so when I think of the state-of-the-art, we've advanced the state-of-the-art to the point where now we can replicate a cell failure with sufficient energy to cause that venting to propagate to subsequent cells in the battery, and that's where the current state-of-the-art is today.
Mr. Chairman, can I continue? Just for my edification, 300 kilojoules sounds like a lot. Can you just explain? I'm sure everyone else here knows what a kilojoule is. Could you just explain what a kilojoule
Apologize.
is? I don't know what it is. So.
It's a good way to think about it is the cell of the battery That's about 30% more energy than that cell contains when it's fully charged. So you can think about overcharging a cell by about 30%. That's the amount of energy that we're talking about.
Oh, okay. All right. I'll have a second round.
Ms. Johnson? Your questions now? Back to you.
Sure, great, thanks. So with the new state-of-the-art, would you argue then, would you argue that will be the state-of-the-art? Is that going to get in the literature for the next lit review, and this is how you're supposed to be doing it because we know better now?
I would imagine that for the immediate near term it would be, until somebody thinks up a better way to do it. One of the ways we might not like it is that it's over-conservative at this point. We add a lot of energy to the battery to make it do what it does, and you never want to be over-conservative. You kind of want to hit the sweet spot, but for right now, being over-conservative is better than being
And by over-conservative, you mean you're really stressing the battery beyond what anyone would ever think it would be doing?
That's correct.
Yeah, so it ends up not being a realistic situation?
It encompasses all realistic situations and then some. And it gave us great confidence with the battery enclosure that we've designed to go around the battery. In fact, in our certification testing on the airplane, with the airplane operating and the engines running, we wrapped that same heater element around a cell inside the battery in the newly designed enclosure, and we put that same amount of heat into that battery cell and caused the battery to fail on the airplane while the airplane was operating, pilots on board, engines running, in a conformed certification test, and demonstrated that even while that single cell failed, the battery continued to operate for the next hour, and the airplane continued to operate normally throughout the entire event.
Are you involved with the ODA process?
I'm involved as the applicant. Inside Boeing, we kind of have a firewall between the delegated organization and the applicant, which is the designer, the builder, the requester of the certificate. I'm the designer and builder. Okay,
yeah, you're getting at the crux of my question, because if Boeing is an ODA or has an ODA designation, we have FAA working with the ODA within an organization, but that organization also then is designing, building the equipment, in this case an airplane. How do you keep those separate? Because the watcher is watching the ODA is supposed to be watching the maker, but if the ODA and the maker are under one roof, then how would we look at that and say, well, we need to have more separation?
To a large degree, it's a process-based separation that's rooted in our culture. For example, while we're a designated organization today, we've always had designated representatives of the FAA performing aspects of the showing of compliance. Since I started in Boeing commercial airplanes 23 years ago, it has been my history that I was taught from the very beginning that when a Boeing engineer is acting on behalf of the FAA, they are completely independent, and they cannot come under any undue management pressure to do something that's against what they would term as best from an FAA perspective. And that is deeply rooted in our culture. One of the quickest ways to see disciplinary action as a manager is to provide any undue influence over a designated representative of the FAA. And it is in our absolute culture to make sure that they're independent from that perspective. We believe that for a couple of reasons. One, it's one of the primary legs in the safety stool. Our whole industry relies on that. Second, we also understand that without that, the certification process itself would take much longer than it does today, and the net product would probably not be as good as it is today because we wouldn't have the expertise of the individuals who know as much as they do about the individual systems.
Presumably the FAA could pull an ODA status as well if there were any problems.
That's right. The FAA can pull that privilege from us at any time if we're not performing it appropriately. And likewise, the FAA can take an individual who's performing as a delegated representative and remove that individual as well.
Yeah, I'll explore that a little more with the FAA, I think. I've got one last question, and it has to do with all those airplanes sitting on the tarmac at Payne Field, and I know you're moving to get those delivered, and very happy about that. But it goes to the changes. Now that you have you signed off on the new change, the new system with the box and the vent, and then incorporating that now into the production process and the line, and moving those planes out. Does that need to be separately certified as well?
That change,
the process of changing them out, putting the new boxes in.
yes, there were 2 separate certifications. One was really related to the basic type design of the airplane changing to incorporate it, and the other was the certification of the service bulletin that's performed by the airlines to make that modification. Boeing teams did that modification work for the airlines, but that was under the service bulletin that had been approved by the FAA.
And the involvement in developing that certification for the process includes management, engineers, and machinists on the line, making sure everybody is working off the same page?
That's correct.
Yeah, great. That's it. Thanks.
Okay. Mr. Sinnett, we thank you very much, and the subcommittee stands adjourned.
Thank you.